when a freely falling solid ball in a liquid, so let us say that this solid has density rho solid and its radius is r, and the liquid in which it is falling is rho liquid. So we know that when this solid ball is falling in the liquid, there are two forces which will certainly act, and that is, one of the forces its own weight, which will be always acting downward, and another force will be buoyancy, which is equal to weight replaced of liquid. And since this force is unbalanced force, because this solid density is higher than liquid, and because of that, it will be the force mg will be greater than b, and because of that, this force mg minus b will be unbalanced. It will not be zero, and because this is not zero, so there is a net downward force acting on the ball, and because of this, its velocity will start increasing, and as its velocity increases, and because this liquid is a viscous liquid, as soon as this ball gets certain velocity v, as soon as it gets velocity v downward, there comes a force viscous. We say that this viscous force start acting on the ball, which is always opposite to the direction of velocity. So because of viscous liquid, we say that on this ball there will be an extra force Fv, viscous force, which is proportional to velocity. And initially, since this velocity is small, so this viscous force will also be small. So when this viscous force is small, it will not be equal to this unbalanced force Fb. This will not be equal to, and because of this velocity will keep on increasing, but as this velocity is increasing, so does this viscous force, and at certain time, and at certain point, when velocity of ball is sufficiently higher, and it is at a point velocity at vt, we say that at this velocity, what will happen, that this force balances, mg minus b is equal to viscous force, and since this viscous force balances this mg minus b, this unbalanced force, so now this force is, so the net force on this ball is 0, and after that there can be no increase in this velocity, and this certain velocity is called terminal velocity. So whenever a solid ball is allowed to fall in a liquid, its velocity cannot keep on increasing indefinitely. So after a certain time, what will happen, that this mg minus b force get balanced by this buoyancy or viscous force, and at that point there will be no further increase in the velocity, and with this velocity the ball can now travel in this liquid further, because this force is constant and Fb is also constant, because ultimately velocity is not changing, so viscous force will also not be changing. And this viscous force was measured, and this viscous force was measured, and this value was 6 pi r neta and velocity v. So as this velocity increases to terminal velocity vt, we say that this viscous force is equal to mg minus vt. So we can now write this force, we can now write this equation, mg minus b is equal to 6 pi r neta and vt, and we can solve for vt. So mg can be written as 4 by 3 pi r cube rho solid g minus 4 by 3 pi r cube rho liquid into g, and this should be equal to velocity 6 pi r neta and vt. And after solving we can find out what is the terminal velocity vt, and that will be, you can solve it and you will see that this is 2 by 9 r square by neta rho solid minus rho liquid into g. So this is the formula for terminal velocity. So let me summarize this once more. We says that whenever there will be a case of a freely falling ball in a liquid, its weight will be greater than buoyancy, and this force is unbalanced, and because of that its velocity will start to increase, and as soon as this ball gets some velocity, a viscous force start to act in the direction opposite to the velocity, and this viscous force opposes further increase of velocity. But since this mg minus b is greater than this viscous force, so this velocity will keep on increasing, but as velocity is increasing, so does with this viscous force, and there comes a time when this velocity will become vt, and at that velocity this viscous force is equal to mg minus b, weight minus buoyancy, and at that time this viscous force get balanced by this viscous force. And so we say that this is the terminal velocity. Now there can be no further increase in the velocity, because ultimately the net force on this ball is 0. mg minus b minus fv is 0. So now there will be no increase. So this velocity is called terminal velocity, and this is the formula that you should remember. And you can see that almost every year, not almost every year, but you can see that this is a very easy concept, and you will see that there are always some question asked in the JEE Mains and NEET examination on this formula only. In 2025, I recently just solved yesterday, there has been a question in which terminal velocity is given, radius is given, density of solid is given, liquid is given. So it is asked what is the neta, coefficient of velocity.